Hello and welcome to this lesson in our study of linear algebra. This is lesson 3 of the linear algebra 2, and our topic for today is bilinear forms. Okay, so when you have any vector space V of finite dimension over a field K, okay, then the bilinear form on V is a mapping. That's U cross V maps onto K, and it satisfies the following conditions. Okay, so we say that the bilinear form, this is linear in the first variable, okay, and the second condition, that's what is linear in the second variable. Okay, also when you have any n by n matrix A, we can view A as a bilinear form defined by this. Okay, so we choose a vector X, okay, and X is of finite dimension. Okay, it have finite number of elements in them, so this X, okay, and any square matrix, okay, that's this one, and a vector Y of finite dimension, that's it. Okay, then the bilinear form on this is given by X transpose AY, okay, and this X transpose matrix A and what Y. Okay, so when you solve this, you get this. Okay, that's what you will get, right? So now you get what A11 Y1 X1 Y1, A12 X2 Y2 up to ANN XN YN. Okay, so now let's look at this example. When you have H, okay, that's two vectors of 2 dimension, right? So we have A1 A2 B1 B2 equals to this. Okay, so you can write this in the form of a matrix. Okay, so A1 B1, okay, the coefficient of A1 B1 is 2. This means that the element we normally use, A normally indicates the row number and B for column number. Okay, so A1 B1, that's element the first row first column. Okay, that's 2, so that's what we have here. 3 A1 B2, that's element on the first row second column, that's 3, and that's what we have here. Second row first column, that's 4, then second row second column, that's what we have here. Okay, so that is, we have generated our matrix from this. Okay, so now let's look out for some examples. Let's look out for some examples. Okay, so now we have a very nice question here. A very nice question. So we let F be a bilinear form on that is 2 dimension defined by this. Okay, defined by this. Now we are to find matrix A of F in the basis. So we have the basis U1 and U2. Okay, so now first of all, we can generate our coefficient matrix from this. Okay, so we let that one be D, such that the elements on the first row first column is given by 2, first row second column is given by -3. You see, there is no element on the second row first column, right? So that's 0. Then second row second column is 1, so we let that one be D. Okay, yeah, that one be D. Now you form matrix A. Okay, and matrix A, you can let you can let A be equal to A11, A12, A21, A22. Okay, then you find the value of the elements, each of the elements in matrix A. Okay, so now A11 is given by f of u1 u1, and from definition, okay, f of u1 u1 is given by u1 transpose d u1, and we know our u1 to be 1 0. Okay, so we have 1 0. This is our matrix D, and this u1. When you solve this, you get 2. The same thing applies to A12. So A12 is given by f of u1 u2. Okay, and this is the same as u1 transpose d u2. Okay, u1 transpose du2, u1 transpose du2. Okay, so that's what we have here. That's A12, right? That's what we have here. So this u1 transpose, this is d, and this u2 is given by 1 1. So when we solve this, you get -1. A21 is given by u2 transpose du1. That's what we have here. Sorry, that's what we have here. Okay, that's what we have here. Yeah, that's A21. Okay, so when you simplify this, you get +2. A22, that's u2 transpose du2. When you solve it, you get 0. So now you know our A11 to be 2, A12 to be -1, A21 to be 2, and A22 to be 0. So we can form our matrix A. Okay, so that's the matrix A. Now let's move on to the second question. So we are to find our matrix B of F in the basis. Okay, so we have V1 and V2. Okay, so now let's form matrix B. So you can let B to be equal to B11, B12, B21, and B22. Then you solve for the unknowns. Okay, so you go through the whole process again. So we have B to be B11, B12, B21, B22. Okay, so B11 is given by, this time around the basis was V1 and V2. Okay, so we have V1 transpose dV1, B12. When you solve this, you get 3. Okay, B12 is V1 transpose dV2. When you solve it, you get 9. B21 is given by V2 transpose dV1. Okay, when you solve this, you get 0, and B22, that's V2 transpose dV2, you get 6. Okay, so that's what we have here. That's how we were able to generate our matrix B. Okay, and for the third question, we are to form our transition matrix P. Okay, here is the question. Okay, let's read the question. So now we are to find the transition matrix P from the basis UI to VI, and we are to also we are to verify that B equals to P transpose AP. Okay, so first of all, let's form our transition matrix. To form our transition matrix from the basis UI to the basis VI, we express VI as a linear combination of the UI. Okay, we express vi as a linear combination of ui. Okay, so now you can pick each of the v. So when you pick v1, you express v1 as a linear combination of u1 and u2. So maybe you have au1 plus bu2. Okay, and this is given by, we know our v1, we know our v1 to be 2 1. Okay, so our u1 is given by 1 0 plus b, our u2 is given by 1 1. Okay, so we solve this, it becomes simultaneous equation of two unknowns. You solve the two equations simultaneously, you solve for a and b. Okay, so when you solve for a and b, you realize that you get a equals to 1 and b equals to 1. Okay, so our v1 becomes u1 plus u2. That's what we have here. Okay, also you express v2 as a linear combination of u1 and u2. You go through the same process again. So v2 is given by au1 plus bu2. Okay, so when you solve that, you get a1 to be 2 and a to be 2 and b to be -1. So you get this 2u1 minus u2. Okay, now when you pick v1 is the same as u1 plus u2. The coefficient will be the element in the first column of the transition matrix P. So we have 1 1 here. Okay, the same thing applies to v2. The coefficient, that's, we have two -1, so that will be the element in the second column. So this was our transition matrix P. Then you can find a transpose. Okay, so now you can check to see if this is true. Okay, if this is true, there is an exercise here. You can pause the video and try your hands on it. Okay, there is an exercise here. So we have we have our bilinear form. We have our bilinear form given by, this. That's 3x1 y1 minus 2x1 y2 plus 4x2 y1 minus x2 y2. That's our bilinear form. Okay, that's our bilinear form. So first of all, you have to find matrix A in the basis. So you have u1 and u2. That's A part. You cannot. Second one, we have to what? Find matrix B in the basis, right? v1, v2, and we are also to solve for the transition matrix P from basis u1 to vi and verify that B equals to P transpose AP. So you can pause this video and try your hands on this question. Okay, so now let's solve the question. So first of all, you see, we're given a bilinear form. Okay, we're given this. So let's generate our matrix D. Okay, so we have, so these three will be the elements in the first row, first column. That's what we have here. First row, second column, that's -2. That's what we have here. Second row, first column, that's 4, and second row, second column. Okay, so we are to use basis u1 and u2 to generate our matrix A. Since this is a 2 by 2 matrix, then our A is also going to be 2 by 2 matrix. So we solve for each of the elements in A. That's A11, A12, A21, and A22. Okay, so now A11 is given by, from definition, f of u1 u1, and is the same as u1 transpose du1. Okay, u1 transpose du1. So this is U1 transpose, this is D, and this is U1. When you simplify, you get 4. A12, that's f of U1, U2, and is given by U1 transpose D U2. And you solve this, you get 1. The same thing applies to A21, that's U2 transpose D U1. When you solve, you get 7. Okay. Then A22, that's U2 transpose DU2. Okay, so when you solve this, you get positive 3. So now A11 is 4, A12 is 1, A21 is 7, A22 is 3. So we can generate our matrix A. So that's what we have here. We have 4, 1, 7, 3. Then the second question says that we are to generate matrix B from a basis V1, V2. So matrix B is unknown, so we can let matrix B be what this matrix, that's B, is it contains 4 elements. Okay, so we have B11, B12, B21, B22. Okay, and this is our basis V1 and V2. So now we find the values of each of the elements of the matrix B. Okay, we find B11, we solve for B12, B21, and B22. Okay, so B11 is given by, this time the basis is V, not U. Okay, so that's f of V1, V1, and is given by V1 transpose dV1. When we solve this, you get 0. Okay, B12, that's V1 transpose dV2. When you solve it, you get negative 4. V21, that's V2 transpose dV1. When you solve this, you get 20. Then B22, that's V2 transpose dV2. When you solve it, you get 32. So now we have our matrix B, who is given by that's B11, which is 0, B12, which is negative 4, B21, which is 20, and B22, which is 32. So this is our matrix B. Then on the third question, we are to generate our transition matrix on given basis, that's from U1 to V1, sorry, UI to VI. Okay, so we are to what, express VI as a linear combination of UI. Okay, so first of all, we pick V1. So we express V1 as the linear combination of U1 and U2. So when we do that, we have this. Okay, so our V1 is given by 1, negative 1 from the question. Our U1 is 1, 1, our U2 is 1, 2. Okay, so you pick each of the first element, okay, in each of the vectors. So this one is given by A times 1 is 1 plus B times 1 is B. So we have our equation 1. Then you also come back to the second element in each of the vectors. We have negative 1 equals to A plus 2B. So we have equation 2. You solve equation 1 and 2 simultaneously. So when you solve it simultaneously, you get negative 2 for B and positive 3 for A. So therefore V1, which is AU1 plus BU2, is given by 3U1 minus 2U2. Okay, similarly we express V2 as a linear combination of U1 and U2. Okay, so that's what we have here. So now this is V2, this U1, this U2, right? So we solve for the unknowns, and here the unknowns are what, C and D, right? So we pick the first element in each of the vectors. So we have 3 equals to C plus D, that's equation 1. Then 1 equals to C plus 2D, that's equation 2. We solve equation 1 and 2 simultaneously. So when we do that, we have D to be negative 2 and C to be 5. So therefore V2, which is CU1 plus CU2, is the same as 5U1 minus 2U2. Okay, then from here we can generate our transition matrix P, okay, using these two, that's V1 and V2, okay. So now when you consider V1, after expressing V1 as the linear combination of U1 and U2, then the coefficient, okay, of U1 and U2 will be the element in the first column of P. You see, we have 3U1 minus 2U2, so you have 3 negative 2. That will be the element in the first column of the transition matrix P. The same thing applies to V2. We have 5U1 minus 2U2, so we have 5 negative 2. Okay, have 5 negative 2. So this is our transition matrix. Okay, and the second part of the question says that we have to verify that P transpose AP is equal to B. Okay, so first of all, we transpose our transition matrix, and the transpose of this matrix is given by this. That's 3 negative 2, 5 negative 2. Okay, so but we already know our matrix B. Okay, so if we want to verify, we are required to solve for this, that's P transpose AP. Okay, so we have this P transpose, the transpose of the transition matrix. This is our A and this is our P. Okay, so first of all, we multiply the first two matrices. Okay, that's that's row by column. You consider the first row, you consider each row, then you multiply by each of the columns of the matrix A. Okay, so 3 times 4 is 12 minus 14, which is negative 2. Okay, then 3 minus 6, that's negative 3. You consider the second row. 20 minus 14, that is 6. Then 5 minus 6, which is negative 1. Okay, then you multiply by this. When you multiply these two matrices, you get this. Okay, that's negative 2 times 3 is negative 6 plus 6, that's 0. This negative 10 plus 6, that's negative 4. 18 plus 2, that's negative positive, so we have 20. And 30 plus 2, that's 32. And this matrix is the same as B. Okay, and therefore we have verified that B is equal to P transpose AP. Thank you.